Hi, this is John Mackie with Neural Netting. Welcome to another edition of the Machine Learning Primer. Today, we're going to be exploring the ML ocean and some strategies on not drowning in it. Thanks for joining me. Let's dive in. Picture yourself setting sail on the ocean, heading out to the deeps and losing sight of land. Selecting an ML model can feel a bit like this, a strange mix of exhilaration and fear. As the multitude of machine learning algorithms unfolds before you and grows by the year, it's normal to second guess selections and perhaps flounder in endless hyperparameter tuning. Having an accurate map to guide model selection can build your confidence that you're headed in the right direction and you'll reach your destination. Before we take a look at our map, let's talk about the stages of model selection. The first one is manual. Start by putting away all the technology and asking yourself, how would I do this by hand? If I was stuck implementing this process manually, where would I start and what would the workflow and steps look like? Thinking this through might illuminate challenges that will be present regardless of the degree of automation. Low tech. Next, think through tackling the problem using traditional software technologies. What would a heuristic, rules-based solution look like? They're usually more cost-effective to build if they fit the bill. Maybe ML is overkill for your problem. High-tech simple. What is the simplest ML model I could use to solve my problem? Or maybe a series of simple models, each one feeding the next, like an assembly line. Is there some way to take off-the-shelf ML models and rig them to solve my problem? High-tech complex. If I had a black box that contained a super sophisticated ML model that solved my problem, what would that be worth to me? If the value provided is high enough, it may be worth pursuing a highly customized solution that perhaps is built upon novel algorithms. So, to recap, before you set sail, it's worth considering all your options, from doing it manually all the way to building a very expensive custom model. Before you spend more than brain cycles, take a step back and imagine you've arrived safely at your destination. Was it worth it? Pretend your ML implementation succeeded beyond anyone's wildest dreams. Did you have an accurate view of the ROI when you started? Some projects take on a momentum of their own, regardless of the final payoff. Make sure there's a pot of gold waiting at the end of your journey before you set out. Here's the map we're going to use to select our ML model. The many different types of machine learning models can seem overwhelming. Knowing which types of models have proved successful in past projects can be the key to applying the right tool to the job at hand. There's three major types of ML. Supervised learning is a branch of ML that involves training our models on data sets that contain the answer. So when deployed, the models can respond to new data points intelligently. Unsupervised learning involves training our models on data sets that do not contain the answer we're looking for. Instead, we're asking our models typically to look for natural patterns in the data or clusters. Reinforcement learning, the third branch of ML, has to do with models that learn by trial and error in an environment to behave more and more intelligently as they receive feedback on their actions. Supervised learning regression. Predictive modeling is one of the most popular types of regression. Say you wanted to predict the price of a house based upon various features, such as location, square footage, number of bedrooms, walkability, etc. You could gather up some data from the public domain, like Zillow, train your regression model on it, and then feed it information on new houses to see what price predictions it might make. Supervised learning classification. We're all too familiar with the automated tagging and classifying of uploaded images to services like Facebook, Instagram, and Google Images. This type of ML model excels at placing something in a discrete category or class based upon some attributes present on the input image. Unsupervised learning, dimensionality reduction. Sometimes the features we input into our machine learning model aren't all that useful. This is where dimensionality reduction comes in. Using techniques like principal component analysis or PCA, you can reduce your original input features to just those actually helping and getting to the desired answer. Unsupervised learning clustering. Clustering is an unsupervised learning approach by which the machine learning model is asked to find patterns in the data. We're not telling the model what to look for. Instead, we're asking it if it can see anything interesting in the data. This technique can be useful for grouping like minded customers together for the purposes of making future recommendations, like at Amazon. Reinforcement learning. Gamers may be familiar with the breathtaking success DeepMind had with their AlphaGo system against top rated professional players of the game of Go a few years ago. Under the hood of AlphaGo was a sophisticated implementation of reinforcement learning, where the machine learning model became more and more adept at playing the game of Go the more it played it. Okay, let's put our map to use on some real world use cases. The following examples illustrate what types of models are useful in solving which types of problems. So keep the map in mind and feel free to guess as we go through these. Okay, so the first example, diverting defective products on a production line. This would be classification. Image classification using convolutional neural networks or CNNs. Building an enemy for a game. Definitely reinforcement learning. Predicting the sales price of a car. Hopefully you guessed regression. Targeted marketing campaign based upon past purchases. This would definitely be clustering. Categorizing posts on a forum. Probably classification, natural language processing, NLP, probably using recurrent neural networks or RNNs. Detecting fraudulent activity on a credit card. This could be classification or clustering. Both approaches are useful for anomaly detection. Providing insight into vast amounts of data with charts and graphs. Great fit for dimensionality reduction. By now, you should appreciate that although the field of machine learning is indeed vast, there are some well-established boundaries that make navigating it much simpler. Start by assessing the level of automation appropriate for the problem at hand. Be sure the risk is worth the reward. Then identify the ML category your business problem best fits in and get to Googling to see examples of how other ML practitioners have tackled similar challenges. There is plenty of collateral out there to use as a starting point on your next project. Just check out the Notebooks tab on Kaggle for some great inspiration. Remember, reinventing the wheel is never the right answer. That's it for this episode. Thanks so much for watching. If you got something out of it, please click on the thumbs up icon below and subscribe to the channel if you'd like to see more episodes in the future. Hope to see you next time, where we'll be looking at the two very different career paths in machine learning and the roles they play on projects.